Now, on Thursday, we looked at the properties of quadrilaterals, and I sent you away and I said, try and complete this diagram. And let me just close that. There's so many things open here on my computer. And I thought I'd quickly run through them with you. If you tried it, great. If you didn't try it, you can take a screenshot now, but you do need to know these properties really, really well. Okay, so this is just that one filled in. So it's like the memo of it. So we're going to start with the trapezium. One pair of opposite sides are parallel. Don't worry about the area formula. We're not going to do area now, but it is there. It's more like you use that more in grade 9 and stuff for area. Okay, so the highlighted property is what we say is the defining characteristic of that shape. So both pairs of opposite sides parallel. That is what makes a parallelogram. And then the other ones follow from that. If it wasn't for that first property that's highlighted, that shape will not be a parallelogram. It would be something else. It's like the shape's DNA. Okay, so if my DNA was different, I would be someone else. So if the parallelogram did not have both pairs of opposite sides parallel, then it would be something else. Okay, so you got to know that first one and then the ones that follow from it. Then the kite, two pairs of adjacent sides are equal. And the way that you can remember this now is that we've got trapezium, parallelogram, kite. And all of these that follow, rhombus, square, rectangle, they are also parallelograms, but they are special parallelograms. So the rhombus has all the properties of a parallelogram plus the ones that are listed underneath it. The adjacent sides are equal, the diagonals bisect at 90, and the diagonals bisect the angles. So if you learn the properties of a parallelogram really well, then you already know some of the properties of a rhombus, square, and a rectangle because of that overlap. And you'll remember last week on Thursday, also, by the way, if you're new and you want to catch up on some of our lessons, maybe the Thursday lesson that's passed, you can watch the recording. All the recordings are available on the website and on YouTube as well. Okay, so a square is a parallelogram, so it's got all the properties of a parallelogram plus these additional ones. Adjacent sides are equal and the interior angles are 90 degrees. So if we're going to define a square, we define it as a parallelogram with adjacent sides equal and interior angles that are 90 degrees. That's the definition of a square. And then lastly, the rectangle. The rectangle is a parallelogram with interior angles that are 90 degrees. Okay, and then you can even go further and say that the square is a rectangle and the square is also a rhombus because it has all the properties of a rhombus in addition to the fact that it's got the interior angles that are 90. And a rectangle or a square is also a rectangle because it's got all the properties plus the 90 degree property, the interior angles are 90 degrees. Okay, so squares are rectangles, but rectangles are not squares. Okay, the sort of mother figure is the rectangle. They all actually come from the parallelogram, rectangle, square. And then the same with the rhombus. A square is a rhombus, but a rhombus is not a square. Okay, I hope that I've explained that well enough. As we go, we'll practice this like as we go along in the lessons. we're going to practice it every lesson. It is that important. Okay, you got to know your properties of your quadrilaterals. And you can take a screenshot of this. Most welcome to do that. I'll hold it there for a second, and then I'll scroll down so that you can see the rest. 5, 4, 3, 2, 1. Next. 5, 4, 3, 2, 1. Okay. Any questions about that? Let's raise your hand. We're all good. Okay, now why do we need to know these properties so well? So that we can calculate angles and sides, so that we can identify quadrilaterals as the correct one of these 6, and so that we can use their properties. So if we don't know the properties, we can't even begin to identify them correctly. So that's why this is our starting point, to first get to know them really, really well. Okay, let's start with this. And so that's what we're going to start doing today, is we're going to calculate angles in quadrilaterals using their properties. So we'll keep coming back to this diagram if we need to, but hopefully you just know it now that you've seen it once. Just kidding, just kidding. Okay. Right, let's do the first one. Calculate the missing angle X. Anyone want to venture an answer? Pop it in the chat. Let's see. If you pop an answer in the chat, also give a reason. Remember, geometry is all about reasons. And they are stumped. We are working with quadrilaterals. We don't have any straight lines. What do we know about the interior angles of a quadrilateral? Yes, Isa, the interior angles of a quadrilateral add up to 360. Now try again, guys. What is X equal to? Okay, right. It is 93 degrees because the interior angles of a quadrilateral add up to 360. So our reason here is interior angles of a quadrilateral. Now, the best we can do here is say that this is a quadrilateral. Can we say that it's a parallelogram, a kite, or any of the other ones? No, we can't. Because do we see any of those defining features? Any of those defining features that we just went through? The DNA that we talked about here? No. We can't make it up because this is not English where you make up stories. This is maths. You can only work with the hard facts here. And there is nothing that can make us believe that this is a parallelogram. Sometimes we aren't sure yet until you find the what, Tandukazi. I want to hear this. The answers. Yeah, but we can't make up properties. Jokes aside, we can't make up properties. Now, let's go to the next one. Nishan is giving us answers for the next one already. First, the first thing you do is identify the quadrilateral. Now, what have we got here? Guys, vertically opposite angles only work on straight lines that cross. Vertically opposite angles don't have anything to do with opposite angles like this. Okay, let's clear that up as well. These are opposite angles, but they are most certainly not vertically opposite angles. These angles would be vertically opposite because they are on straight lines that cross. But if you are working in a shape, in a quadrilateral, then we can't say that, we can't mix things up, okay? It's either vertically opposite, and if we're on a shape, they are just opposite. Okay, so this quadrilateral has equal side, opposite equal sides. So Emmanuel says the shape is a rhombus. So let's go to our properties here. The adjacent sides are equal. Adjacent sides are equal, goes for a square as well. Okay, so adjacent sides are equal. And what does that make it? A square or a rhombus? Let's go back to our properties. It says the adjacent sides must be equal and the interior angles are 90 degrees for a square. And a rhombus, the adjacent sides are equal. So which shape is this again? I ask you, grade 10s. This is a rhombus. Yes. If this angle was not 115 and it was 90, then it would be a different story. But it's 115, so it's a rhombus. Okay. So what can we say about x? What is x equal to? What is y equal to? And what is z equal to? So if we have identified it as a rhombus, now we can use the properties of the rhombus to solve for x, y, and z. So before we carry on, just listen. What are the other properties of a rhombus? We've now identified it as a rhombus because of the adjacent sides being equal. Now I'm going to change colors because now that you've done that thinking, now you use that fact to find the other properties. And what did we say they were? The other properties are diagonals bisect. There are no diagonals drawn here, so we're not going to bother with that. And then the diagonals bisect the angles, okay? But what do we know about the angles across from each other, the opposite angles? And what do we know about the sides? The sides, the opposite angles are equal. Well done. Opposite angles equal. And the sides, the opposite sides are going to be parallel because a rhombus is a parallelogram. Yeah, all the sides are equal, not just the opposite sides, all the sides. Okay, right. So that's how you approach the question. You first identify the shape by its defining characteristic, its DNA, and then you use the shape's properties. You don't just jump in and start hoying stuff around and saying, oh, it's this, oh, it's that. Okay, it's like being a detective. You need the facts. Okay. Now, let's see. There are some answers. So, Sibonga Musa is saying that x is 65. I agree because of the co-interior angles. Some other people have said that as well. So you guys are on the money there. Then y is 115 degrees. And the reason there is opposite angles of a rhombus. Not vertically opposite, just opposite angles of a rhombus. Okay, and fill them in as you go. So then x is 65, y is 115, and z is how much? Z you can do in two ways now. Give a reason. Nice, Sibunga Muso. Yes, Z is 65. Okay, let's go around again. So the properties of a rhombus tell me that all the sides are equal, yes, and the opposite sides are parallel. So we're going to use the parallel sides to find x is 65 because of co-interior angles. Guys, please remember to remain on mute. I hear it sounds like someone's eating chips in the background. And then y is 115, opposite angles of a rhombus. Never ever write properties of a rhombus. And then Z, because it's not the properties of the rhombus. A rhombus, as you can see, has many properties. Which property will make that angle equal to 115? And it's opposite angles. And then Z is 65, and you can do opposite angles of a rhombus, or you can do co-interior again. Okay, right, so that's how you approach the question. Let's carry on. Let's do another one. Let's not do 2. Let's go to question 5 here. I'll go through that same process again. We identify the shape. And then we use the properties of the shape to solve for angles. Okay, we have to be sure. We can't say could, maybe, etc. It either is or it isn't. Okay, guys, that's just how it is. That's what makes maths nice, is because it is or it isn't. Unati, yes. If you are saying, by the way, those in the chat who are saying it's a parallelogram, give us a reason. Unati, what is, you have your hand up? You can unmute.
Sorry, ma'am, can we go back to the last equation that we were doing? I have a question on it.
Okay.
I have a question on how we got 65 degrees, ma'am.
For which one?
For X.
Okay, so you understand that it's a rhombus?
Yes, ma'am, I do.
And that the opposite sides of a rhombus are parallel?
Yes, ma'am.
So if the opposite sides of a rhombus are parallel, then we can use co-interior angles. So this is 115 and that is X. So together they're co-interior, so they must add up to 180.
Oh, yes, ma'am. Yes, ma'am.
That's how we got the 65.
Oh, thank you, ma'am.
Okay, great. You guys are getting it sort of right because you're saying parallel sides and stuff. The only thing we are given here are the parallel sides. There's nothing here about it being equal, only parallel. We can only work with what's there. We cannot make things up. So this is a parallelogram because both pairs of opposite sides are parallel. Okay, be very clear, guys, that in this question, what we are given are the opposite sides are parallel. That's what makes this parallelogram a parallelogram. Don't make stuff up. There's nothing here that says that the sides are equal. Now that we know that it's a parallelogram, we can say opposite sides are equal. But the reason why this is a parallelogram is because the opposite sides, both pairs of opposite sides, are parallel. Okay. How many reasons do you need to prove what type of quadrilateral it is? Just one. the defining characteristic that I talked about, the DNA of the shape. Okay, so this is a parallelogram, and you can abbreviate it like that. Both pairs of opposite sides parallel. Okay, so now that we know that it's a parallelogram, we can use all its other properties, and we can say, what is X, what is Y, what is Z? What is X equal to? Put it in the chat with a reason. We're about 70 strong in this class at the moment, so I want to see a lot more answers in the chat with reasons. Okay, good stuff. Yes, X is 70. And the reason for that is co-interior angles. And then Y, let's see, what is Y with a reason? And write in as you go. So this is 70. You can do it two ways. Okay, we can do Y in two ways. The opposite angles of a parallelogram are equal. Or we can do co-interior again, going this way around. I'm going to go with the opposite angles of a parallelogram. And then what is Z equal to? Ms. Coca, will you help in the chat, please? Thanks. Z is equal to, pop it in the chat with your reason. Z is also 110 because the opposite angles of a parallelogram are equal. Okay. Not vertically opposite. When you are working in parallelograms, there is no such thing as vertically opposite angles, only opposite angles of a parallelogram. Okay. Good. Right. Now, for question 3, sorry, the questions are all, they're actually going like that. For question 3, I'm going to leave you alone for 2 minutes, and I want you to write down, first of all, what is the shape? Why do you say it is that shape? And then solve for X and Y. Just on your own where you are, not in the chat. Let's just wait. With answers, we'll check back with answers in about 2 minutes. Remember to pop a question, number 3, yes. Pop a question in the chat if you have one, or send it over to Ms. Coco, or raise your hand. Remember, if you haven't memorized the properties yet, or you don't know them so well, you can refer to your screenshot that we just did at the start of the lesson. Let's hold your answer, Sibunga Musa. It's okay. And make sure of your words. The words of these properties are like the words of songs. You can't change them. They're copywritten. Kloklo, hold on. Not in the chat yet. Okay, since you all seem so eager, let's just go for it. Okay, so first of all, put in the chat, no worries, Kloklo. Put in the chat what shape it is and why you say it is that shape, for what reason. Come on, grade 10s, what shape is it and what is your reason? There we go. Okay, sure. Maybe it was just my internet connection. It was so quiet for a while there. It's a kite because two pairs of adjacent sides are equal. Nice. Okay, so now tell me, what is the value of x? Good stuff, everyone. What is the value of x? Give a reason. I want to know how 99 came about.
I was about to ask the same question, ma'am. Like 99, I need to know.
99 problems, but a kite isn't one of them. Okay, let's go back to the properties of a kite. It's fine as hell. I was like, huh? That must be a typo. Okay, so what does it say about the properties of a kite? One pair of opposite angles are equal. And then the diagonals one diagonal bisects the other, and one diagonal bisects angles, and the diagonals are perpendicular. So for x, we are definitely going to say that it's 100 because one pair of opposites angles are equal. So you can say opposite angles of a kite. And then how will we do y? Lesego says it's 57. And Nati says 57 because it's co-interior. Co-interior only goes with parallel lines. No problem, Tandakazi. Let's do y. Now we've got 37. Okay, how do we know it's 37? I don't see reasons. How did we find the 37 or the 57 or any of the other numbers? The angles add up to 360. And Emmanuel says 57, some of the interior angles. Okay, so this is the only other thing we can know about this is that it's a quadrilateral. So the angles must add up to 360. So it's 360. Yes, very well done, Sanaku. 360. And Sammy also said that. 360 minus 123 minus 200 is 37. 37 degrees. Okay. And that's the good reason in Kosanati, interior angles of a kite. Okay. Right, we've got a few more minutes left. And that's just what you do. You must know your properties. You must identify your shape and then use your properties to solve for the angles. Okay, we're going to go on to something a little bit more advanced, where we actually now have to also make some equations. Okay, but I'm going to start with question, because it's 100 and 100 is 200. 100 and 100 and 123, that's altogether 323. Now it's Siamu. Of course, interior angles of a kite. The interior angles of a kite add up to 360, like all quadrilaterals. All quadrilaterals have that property. That's what makes them quadrilaterals. Okay, let's go to this question. Let's start with question 2. We're going to do it in a bit of a reverse order. And let's solve for x. So again, I'm going to leave you for 2 minutes so that you can think about it and try it first. Identify your shape and then use the properties to solve for your variable. The opposite angles. We're doing 2. Sorry, Ms. Coco, we're doing 2, not 1. We're doing a reverse order thing. Sorry, I'm confusing everyone, but it's 2. We did 6, now we're doing 2, you know, just changing the order a bit. But this is a new page. Not yet, Sandicilia. Let's just give it 1 more minute. There is no Y for this one, but there are for some of the other questions. There are Ys. But you can keep looking for it. Okay, so first step is to identify the shape. I wonder, Sandisile, do you want to unmute and tell us how you did it? Okay, so we're going to identify the shape first. So I think everyone's in agreement that it is a rectangle. Why is it a rectangle? Opposite sides are equal and the corners are 90 degrees. Now that we know that it's a rectangle, yes, Unati?
Oh, sorry, ma'am. I wanted to check if I did it in the correct way, because I said that since it's a rectangle and we have bisecting angles, and we know that P, the down angle of P is equal to 118 degrees. And then I said that since they are vertically opposite, the other angle too is equal to 118 degrees. So I was trying to calculate for the other angles in order to use the isosceles triangle properties to calculate X. And so I added 118.
Oh, I see. Okay, yes.
Yes, ma'am. So I added 118 up with the other one, and the answer came out as, oh no, yeah, I divided. That's the thing, I divided. Oh, I added 118 up with another 118, and then I subtracted it from 360 degrees. And then I was 124 degrees.
Okay, so let's go slow. Let's go do this one first. So this is 62.
Yes, ma'am, it's 62.
And then where did you get the isosceles triangle from?
Oh, I used the properties of the isosceles triangle because I saw that this angle V is equal to 90 degrees.
Yeah.
So I said 62 plus 90 degrees plus X is equal to 180 degrees. Reason is isosceles.
But how did you know that VPK is an isosceles triangle?
On that one, ma'am, and the thing is, I don't see the opposite angles are equal.
Yes, but my question is, how did you know that that was an isosceles triangle? And I hope that you got it from the fact that the diagonals of a rectangle are equal in length and they bisect.
Oh yes,
so
they bisect.
That's where I hope you got it from. So these are all equal. These are all equal. There we go. And then you did the whole interior angles and you divided by 2. Well done. Yeah, no, that's right, Unati. That's good. I think you were just, remember about the diagonals that bisect. Okay. Good stuff. So we get the 62 because of angles on a straight line. And then we are going to work with the interior angles of a triangle to find X here and X here, because we've got an isosceles triangle if we use the properties of the rectangle, because the rectangle has diagonals that bisect. Do you guys see how important it is that you know these properties really well, because otherwise you can't solve the question. Okay, so let's do that. We can say that X is equal to, let's write the whole thing down. So KPV, angle KPV is equal to 62 angles on a straight line. And then we're going to do X is equal to 180 minus 62 divided by 2, that gives me 59. X is equal to 59, and that's angles, opposite, equal sides, and you are using angle sum of a triangle. Okay, so Shiraz got 59. There we go. Anyone else got 59? Yes, Nishan also got 59. Well done, everybody. Okay, I'm going to put the next two up for you to take screenshots of. Question 1 and 6. And I want you to give it a go at home this week before Thursday, if you can. It will really be good practice. And then we'll pick it up again on Thursday. Okay, but well done. Good job.